Today's masterclass will be dealing with USG Basics-3. So it is part 3 of USG Basics. So let's see USG Historical. So Pierre Curie discovered the piezoelectricity, and piezoelectric effect is the one on which USG works. So it was discovered by Pierre Curie. Carl Lusig was the first one to attempt first USG in the imaging of head. Then John Weil is the father of medical USG. And Ian Donald is the father of obstetrical USG. Purpose of telling this is that these could be asked as question. So always remember that Pierre Curie discovered piezoelectricity. Carl Lusig was the first one to attempt first USG in imaging of head. John Weil is the father of medical USG, whereas Ian Donald is the father of obstetrical USG. Now let's see biological effects of ultrasound. So biological effects of ultrasound, they refers to the potential adverse effect of the imaging modality on the human tissue. So these are primarily via two main mechanisms, that is thermal effect and apart from this mechanical effect. So here, due to law of conservation of energy, all of the sound energy gets attenuated by the tissue and must be converted to other forms of energy. So energy enters body, attenuated by body tissue, energy get deposited and heat is produced. So the majority of this is turned into heat. As such, it is possible for ultrasound to raise tissue temperature by up to 1.5 degrees Celsius. So heat production is greater in Doppler USG. Now this could be measured with thermal index. Now thermal index, it is the ratio of power produced by the transducer to the power required to raise a tissue in a beam of 1 degree Celsius. So this is thermal index. Now let's see mechanical effects of this ultrasound. So the mechanical bioeffect of ultrasound refers to the damage caused by the actual oscillation of the sound wave on tissue. So the most common is referred to as cavitation or microcavitation. This is the most common one. Apart from this, during compression, pressure increases, and during rarefactions, pressure decreases. Air fluid interface is more in lungs and bowel. And mechanical index is less than 1.9. So mechanical index, it is the value that attempts to quantify the likelihood of cavitation by an ultrasound beam. So this value is readily displayed on the ultrasound screen and is recommended that it is kept below 1.9. Most common piezoelectric crystal is lead zirconate titanate, and this we have already discussed in USG Basics 1. So let's see few important points on which questions can be asked. So optimum Doppler angle value, ideally it should be 0, and which is oftenly used as 60 degree, but never to be used as 90 degree. Okay. So probe used for thyroid USG is linear probe. Most common method of display of USG is B mode, that is brightness mode. In ophthalmic USG, A, B mode and Doppler can be used. Doppler effect refers to the change in frequency of sound. So all these are important points